Good evening, welcome to the homework portal. This is week number 5 and this week we are discussing about the problems related to rotation. Okay, so as you know, so far we had been doing only problems related to SL portions, and this week I thought, based on your request, we'll do some problems related to HL portions also. So there are 5 problems in this which will span from 30th September to 4th October, so which I have put it across. For SL students who are studying in IB2, so for you people, I have already put across 5 problems related to mechanics, because mechanics problems I have not done any problems so far, so I have put across some questions on it. So tomorrow you will be getting the worksheets. Anyway, so now let us begin with this. So fine, okay, I think everything is adjusted correctly. Right, now let me see, this paper is for 2 plus 1, 3 plus 1, 4, 4 plus 2, 6 marks. Okay, this is a much lower value here. Okay, so let us do this. Just give me a moment, I will adjust the timings so that we'll try to finish within 6 minutes. But many a times nowadays the problems are going beyond my control and I need to say more than what is required. So sometimes it goes. But anyway, let us try it out to finish within that time. Oh, I have fixed it for 6 minutes 38 seconds. Okay, let me make it a 0 here. Let's see how much does it go with. Okay, now, right. Okay, so let us begin. First question, which will be published on Monday, tomorrow evening. So a bar rotates horizontally about its center, reaching a maximum angular velocity in 6 complete rotations. What is given? Value of 6 is given. Switch on the timer. Right. Okay. The bar has a constant angular acceleration of 0.11 radian per second square. Alpha value is given. Moment of inertia of the bar about the axis of rotation. Value of I is given. Show that the final angular velocity of the bar is about 3 radians per second. What is got to be asked? Omega f to be found out. So which equation will you use? So you can use your equation omega f square is equal to omega I square plus 2 alpha theta, right? Which is this? This is nothing but v square equal to u square plus 2a, same formula. So now what is omega f? You need to know. Omega I, it says a bar rotates about its center, the bar has a constant acceleration, it started from rest, which means what? Omega I is equal to 0 plus 2 into alpha. What's the value of alpha? 0.11. And what's the value of theta? Theta value is not given, but it says it made 6 complete rotation. See, for one complete rotation, it describes what's the angle. Let us say this is the starting point. Okay, one complete rotation, it describes 2 pi radians. 2 complete rotations, 2 into 2 pi, right? Similarly, if I have 6 complete rotations, which will be 2 pi into 6 over here. So it's the total number of radians which this bar has described, right? So therefore, this should be into 2 pi 6 for theta. Okay, so when I do this, let me see what is the answer we get here. So this should now be equal to, use my calculator, right? So this should be 2 star 0.11 star 2 star 3.14 star 6, which should now be equal to 8.184. 8.184, and I need to get the square root of this. Square root of this will now be to 2.86. 2.86 radian. Thus omega f is equal to 2.86 radian, which is close to 2.9 or 3 radians, as expected. 3 radians per second. 3 radians per second. Okay, now let us move on to the next one. Draw the variation with time t of the angular displacement theta of the bar during the acceleration. What is angular displacement? So towards it, now what we do is, see, first you look at what is the linear displacement. Okay, so your linear displacement will be given by s equal to ut plus half at square. Now we are going to apply the same thing. Angular displacement, yes, I am replacing with theta, and this u is nothing but omega I, angular velocity, initial angular velocity, which will be 0, plus half into a is replaced by alpha t square. So it should be half alpha into t square. So which means that theta is proportional to t square over here, right? Which means what kind of curve? Parabolic curve. So you should get a curve like this over here. Get a curve like this over here. That's it. Okay, next. Calculate the torque acting on the bar while it is accelerating. Torque. What's the formula for torque? Tau is equal to I into alpha. What is I? 0.11. What is the value of alpha? Is the value of alpha given? Alpha value was given, I think, right? Alpha value is also given. Alpha value is 0.11. What is the value of I? 0.216. Okay. Value of alpha is 0.11. 0.11 multiplied by 0.216. Let us calculate this. How much will this be? 0.216 multiplied by 0.11 will give you 0.02376. 0.02376, which is 2.37 into 10 to the power of how much? 1, 2. So here it is 1, 2, 2.3, 10 to the power minus 2. What is this now? Tau. Tau is nothing but torque, which should be Newton into meter. This is the right one. 2. What is the mistake I have made? This is one more power is there. Let me check what is the value here. 0.0216. Oh my god. Okay, I made a mistake here. There should be 0.0216, which means there will be one more 0 over here. One more 0 here, which will lead to 2.37 into 10 to the power of minus 3 Newton meter. Now it's correct. Okay, now let us move on to the next one. The torque is removed. Okay, so when the torque is removed, the bar comes to rest in 30 complete revolutions. Once again, the value of N is given. Whenever this complete revolution is given, you can find out the value of theta by using 2 pi n, where n is a number of complete rotations given. Okay. Then with constant angular deceleration, determine the time taken for the bar to come to rest. Okay. It was asking you the value of T over here. Now, to do this, now what we do is let us use the formula theta equal to omega I plus omega f divided by 2 multiplied by T. Which formula is this? S equal to u plus v divided by 2 into T. When can we use this? Average velocity. We can use when the particle is undergoing uniform velocity. Now here what's happening? Uniform angular velocity, right? So uniform acceleration. So here it is uniform angular deceleration. Okay. So now what is omega? What is this theta? 2 pi n, which should be 2 pi into 30. And then what is omega I? Omega I is it comes to, so what is the initial value? Okay, when the torque was set up. So this was seen to be the angular velocity which we got here, which is 2.9. So we will take this as 2.9, right? 2.9. And then when the torque is removed, ultimately it keeps on rotating and comes to rest, which means what? The final angular velocity should be 0 divided by 2 multiplied by T, right? So your value of T will now be equal to 2 pi into 30 into 2 divided by 2.9. Okay, let us do this value. How much do I get? It should be 2 star 3.14 multiplied by 30 multiplied by 2 divided by 2.9. So which would be 129.93, which is nearly 130 seconds over here. 130 seconds. Thus, we are able to complete this within the stipulated amount of time. Maybe we have taken some more long time. Okay. So we will continue with the next problem in the next video. Thank you. So please do all the problems yourself first and then proceed on to looking at the solutions. Okay. Thank you.